Hello, welcome back. In this video, we will begin to introduce Avl Trees in chapter 20. In the preceding chapter, we introduced binary search trees. On average, the search, insertion, and deletion time in a binary search tree is order of log n time. Order of log n is the height of the tree on average, and the tree is balanced. But there's no guarantee for this average case. In the extreme situation, all the nodes can be in just one line from the root and to the leaf. So this becomes linear, and the time complexity, it's order of n for search, insertion, deletion. To ensure the tree is always well balanced, we're going to introduce the Avl trees. So let's look at the definition for the Avl tree. First, Avl tree is a binary search tree. And the second is Avl tree is well balanced. So how do we define well balanced? We're going to introduce the balance factor. The balance factor of a node is the height of its right subtree minus the height of its left subtree. The balance factor. For example, look at the balance factor for this node. 45 is 0 because the left and right subtree, they're both empty. Now this for the node 55, and the right subtree is empty, but there's one on the left. So the height of the right subtree minus the height of the left subtree is -1. And this node 60, the balance factor is 1 because the right subtree, the height is 1 more than the height of the left subtree. If all the nodes, the balance factors are 0, 1, or -1, this tree is called an Avl tree. Now here's another example. And if you look at all these nodes, the balance factor, and you're going to see the balance factors are 0, 1, or -1. So this tree is well balanced. It's an Avl tree. Let's look at the animation. So suppose I'm going to add this 45. So if you insert 45, the 45 is going to be inserted at this location, the right of 35, right here. After this 45 is inserted, you're going to see the balance factor for this node, 25, will be +2. So this node is not balanced. So we need to rebalance it. And by doing a rotation, performing the rotation to rebalance it. So we're going to rotate it to the left. And so this is going to be, you're going to see this 35 and then 25 on the left and this 45 on the right. It's like this. Now, if you delete the 45, there's no problem. So after you delete it and all this balance factor, they're still either 0, 1, or -1. So they're all well balanced. So right now, and this balance factor for 35 is 0. But after you remove 45, and the balance factor of 35 becomes -1. But it's still balanced. So this is fine. All right, so when it's not a balanced, like this situation, if you add 15, right here. After inserting 15, the balance factor for 35 will be -1. So 35 is not balanced, so we need to perform a rotation operation to rebalance the tree. So this will become 25, and this is 15, this is 35. That is all for the introduction. In the next section, we're going to look at the operations and how to rebalance the tree. If the tree is not balanced, we're going to rebalance it. We're going to introduce the operations for rebalance the tree. See you on the next video.